Alright, let's talk about slope and similar triangles. So we got this line, and I made a blue triangle and a red triangle. So let's start with this blue triangle and find the slope. So we're going to go up 1, 2, and over 1, 2, 3. So our slope of the blue would be 2 over 3. Now let's do the slope of the red. 1, 2, 3, 4, 5, 6. Over 1, 2, 3, 4. 6 over 4 you could divide by 2. Oh, I did that one backwards. Let's erase that, in case you forgot. It's always your change in y over your change in x. And like I said, I did that backwards. I did my x over my y. So my y was 4 over my change in x, which is 6. Now I'm just writing it wrong. There we go. And again, I can divide both those by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So both the red and the blue triangles have the same slope, and that's because they're on the same line. Alright, so one more related to this. So would a triangle with a slope right 6 up 5 have the same slope? So if we write that, our change in y, which is our up or down, is 5 over our change in x, which is 6. So is 5/6 the same as 2/3? Well, let's compare those two. So 3 times 5 is 15, 6 times 2 is 12. These are not the same, so no, they would not have the same slope. Alright, so we have two lines here, and we need to see if they are parallel. And if they're parallel, they're going to have the same slope. So they're going to be equal to each other. So let's start with that red one. So it's our change in y, remember, over our change in x. So our y values are -5 and -1. So I'm going to do -1 minus -5. I can change that to a plus or positive 5. And then I'm going to do 4 minus 2. And I'm going to see if that's equal to 7 minus 5 over -6 minus -7. Again, I can change that to plus or positive. Don't really need the parentheses there, I just kind of added them. Alright, so let's work these out. -1 plus 5 is 4. 4 minus 2 is 2. 7 minus 5 is 2. -6 plus positive 7 would be a positive 1. And then I can reduce 4 over 2 by a factor of 2. 2 goes into 4 twice. 2 goes into 2 once. So I got the same ratio, so that means that the lines are parallel. Alright, so now I have two lines here, and we need to determine if they're perpendicular. So let's find the slope of each line. So I'll start with this red one. We're going to go down 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6, 7, 8. So that would be a slope of 4 over 8, which reduces down to, we can divide both those by 4, so that would be 1 over 2. And then the blue line, let's look at what that is. So here we're going to go down 1, 2, 3, oh, I didn't switch colors. 1, 2, 3, 4, 5, 6, 7, 8. And down is negative, so that's a -8, and then I'm going left 1, 2, 3, 4. Oh, I made a mistake on that first one. I went down 4, so that should have been a negative 4, so that should be negative 1/2. And then on the blue one, I went down 8, which is negative, and then I went left 4, which is negative. So that's negative 8 over 4, which you can divide by 4 to give us 2 over 1, because a negative divided by a negative is a positive. So our slope there is 2 over 1 and negative 1/2. So in order for these to be perpendicular, we have to find the product of these two numbers. So we're going to do negative 1/2 times 2 over 1. So negative 1 times 2 is negative 2. 2 times 1 is 2. So I get negative 2 over 2, which equals negative 1, is our product of the two slopes. So are they perpendicular? Yes, because they have a product of negative 1. Let me get a little more room here. Yes, because the product of the slopes is negative 1. So anytime you get a product of negative 1, your lines will be perpendicular.